Sorry for the delay, folks. So you can see we have our little mini unit here on sequences, 2 days of lessons, and then partner quiz. So it'll be next Thursday, January 23rd. Already put that up on the hub, so you'll be able to see it there as a reminder. Let's get right into it. It's going to be a fairly quick lesson, and then you have time to work on the in-class assignment. What's it? There's no technically, it's not, nothing can be due, but highly recommended. Hopefully you'll be able to get to it in class. But again, with the partner quiz, it's kind of enrichment at this point, and it's good to know. It's helpful for when you get to pre-calculus at times, and especially if you're taking statistics, foundational material. So sequence, I think you're already familiar with this word, aren't you? A sequence of events. It's events that happen in some sort of order. Anytime you're dealing with a sequence of numbers, it's an ordered list of numbers. That's at the heart of it. That is exactly what it is. So the inputs could only be 1, 2, 3. 1 would represent the first number, that 2 would represent second number. You can't put in a 3.2 because that wouldn't make any sense to have the 3.2nd item of a list. I hope that makes sense. So here's a sequence. Now, it's sometimes given in function notation like this. Notice instead of an x, we're using an n. Very commonly, n is used to represent what kind of numbers? And now think about it. 1, 2, 3, 4. What kind of numbers are those? Whole numbers. Whole numbers is in the right direction. Natural numbers, or also known as counting numbers. Whatever you put, that starts with 1. So write out the values of f of 1, f of 2, f of 3, f of 4. Is that difficult? Maybe for some, but not for Luke. So f of 1 we know is equal to 1 over 1 squared, which is equal to 1. F of 2 is equal to 1 over 2 squared, which is equal to 1/4. F of 3, can I just go right to 1/9, and f of 4 is equal to 1/16? Are we comfortable with that? So if I were to make this list, it would be exactly 1/4, 1/9. That is our sequence. How high does this go? Infinitely high. We go back before that one, plugging in 0 perhaps. There are multiple problems with plugging in 0, but sequences start with the first term. Write out the terms of the sequence. Oh, I foretold the future. I'll put that there. Or you can. Yeah, thank you. Don't be jealous. Uh-oh. So other notation you're going to see, it looks like what you see here on the left notation. So it could be a sub 1 is how this is written, then a sub 2, a sub 3. Does the word I'm saying make sense? A sub, it's a subscript. A sub 4. So if I ask you for a sub 8, that represents what? The 8th term in a sequence. So this is just ... This is just the terms of a sequence. That's how we denote them often. 8th term of the sequence. Yay. Represent the sequence as a formula for its nth term. Yeah, we need more information. I'm going to skip that C for now and go on to here. Example 2, write out the first 5 terms of the sequence whose general term is given and graph it. This is called the nth term. What's that? No, oh, after, yeah, after, so after example 7, yeah. Okay, so if this is the nth term, and we want to find the first term, a sub 1 is equal to 1 minus 1 over 2. Yeah, the subscripts will always be 1, 2, 3, 4. Yes, plug in 1, 2, 3, 4. In future courses, you might plug in 0, but in our course, that's it. Yeah, that is it. It's very, very straightforward. 0 over 2, which is of course equal to 0. A sub 2 is equal to. Do you see the one? A sub 3 is equal to. Come on. The 3? What is 9 minus 6? That's not 9 minus 3 is 6 divided by 2 is 3. Okay, got it. A sub 4. And so I need to work on these. 6. And one more. A sub 5. And 10. Okay, so we could graph these just as we normally would. So when I plug in a 1, I have 0. When I plug in a 2, I get 1. Plug in a 3, I get 3. Interesting. Is it a line? I'm plugging a 4. I messed up the pattern. Oh, did I do something wrong? I think I put in the wrong thing. 3 is 3, not 2. Sorry about that. And 5 is 10. Should I connect these? If you connect them, that means there's something happening in between the 1 and 2, like there's a sub 1.3. So we don't connect anything. This is what's called a discrete function, meaning you're only plugging in integer values, specifically natural numbers. Yeah. For the first 5 terms of this sequence. Uh-huh. I'll give you a moment to do that. Mhm. Yeah, you have the amazing people behind it. You're not alone. Please show me what we got for a sub 1. 5, exactly. A sub 2? Are you able to show me this one? I'm saying negative 5 halves. Is that what I'm saying? Okay. A sub 3. I'm saying positive 5/3. A sub 4. Negative 5/4. And a sub 5 is 1. So when I'm writing out the first 5 terms of the sequence, I'm just going to write that as a list, just to keep in mind that that's exactly what it is. It's just an ordered list of numbers. That part of the expression is called an alternator. Does that make sense? alternating positive, negative. So you don't actually have to do it every single time. Once you do the first one, you just say, okay, now it's going to alternate positive, negative, positive, negative. I know it's exciting. So taking it a step further, here's a different way to generate a list of numbers. So 1, a sub 2, sub 3, a sub 4, and a sub 5. Let's see if we can figure out each one of these. I mean, 5 different values. Any idea? Check with the neighbor, see what they have. Okay, the first term, what is it? It is -1. The second term, it is 4. How about the third term? Back to -1. Fourth term, 16 and -1. Is that really a sequence though? No? Remember what a sequence is? It's an ordered list of numbers. It doesn't have to be like from smallest to greatest. Don't reorder a sequence. So it is what it is. Right? The fourth one has to be the fourth one. The first one has to be the first one. Cannot be manipulated, even though it's a little bit strange that it like those are all the same. The odd ones are the same. It is what it is. Just a list. Right, the formula for the nth term of each sequence. Okay, so we're going backwards here. They're giving you the sequence. It's up to you to figure out the nth term or the general term of each sequence. Can you already do A? I think you can. Hmm. You never get A sub n? The for number 8, did they get the general formula? What is it? N pi to the n. Is that clear? B, was anyone able to get that one? Yeah, Ben? How did you know that? What's that?
So, how? I did like 1, 2, 3, 4,
Uh-huh.
and then I was like, how would I connect them? And then I saw that all these things.
Oh, nice. Nice. Perfect.
How'd you do it, Jack? I just wrote it down.
Yeah, there you go. That's the way. Just write it down. When in doubt, write it down. But yeah, once you notice, and hopefully you're familiar like that 8, especially. I think for me, I'm saying that 2 cubed, 2 squared, 2 to the 4th, to the first. So that's just 2 to the whichever term in the sequence it is. So 2 to the nth power. And some of these definitely are easier to do than others. Like this one. Let's see what you got. With your neighbor once you're done. Just write it down. The bottom is gonna be 3. The top is gonna be n squared. Any questions? Yeah, what about that 3? Yeah, let's bring it back into the pattern. Yeah, 9/3. And once you have that, it's just about finding a pattern. There isn't always a first thing you do is this, and then you do this, and then you'll have the answer. Just look at it and use your reasoning. Okay, a different way to make a sequence is by something called recursive. Yes. What's the last part? Yeah, whatever term we're asking for. Right, because it's the first term in the series, second term in the series. A sequence, excuse me. Second way to represent a sequence is by assigning values to the first or more value in the sequence and give a recursive formula that tells how to find the next term from those you already know. Okay, I'm going to go back to the first notes way back here for just a moment. I'm going to say if we keep counting, we're going to get to a sub n. I'll also get a sub 10 or a sub 1,000, but if I just have a sub n, what's the number after, what is the term after a sub n? Do you have any idea? A sub n plus 1, does that make sense? And the term just before a sub n? A sub n minus 1. And this is important to realize when you see these n sub n and n plus 1 and minus 1, it's just talking about relation within a or position within a sequence. So keeping this in mind, let's go on back to recursive. Have any of you talked about recursive sequences in any of your classes? There's one class in particular where it comes up. Computer science is huge with recursive sequences. Write down the first, what just happened? That's not what I wanted. Come on back. Sometimes technology. Okay, here we go. Write down the first 5 terms of the sequence defined as the following. Okay. So a sub n, we're going to say for any term. What does a sub n minus 1 represent? The one before. So we're going to say start with the term before then indices. So what's the first 5 terms? I'm going to figure out a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and I'm going to stop there. Do you have any idea what a sub 1 is? Yeah, it tells us it's 12.
What about the bottom?
Well, how about that second term, the a sub 2? Do we have any idea what that one is? If I want to know this one, according to this one, if I want to know this one, start with the term before and add 4. So this is 16. Oh. Now I couldn't do it with 12 because there was no term before. I needed a place to start. So this only works when n is 2 or greater. So the next one is 16. Would you just check in with your neighbors to see if they get that and to finish the sequence? Did you get it? So the third term is 20. How do we know it's 20? It's not any term, we take the previous one and add. Oh, wait. I wonder if the next one. 24. 15. You just wrote it down, didn't you? Yep. It wins every time, except when it loses. And then the last one is 28. Right, so it looks complicated, but it's actually not too bad, I think. I'll give you a moment to talk out any bugs with that one and move on to example 7. Sure your neighbor is okay with this one. Okay, so do we know what a sub 1 is? A sub 1 is 2. Would you please show me a sub 2? It is 6. So we're just adding 4 again. Is that how this is working? Now, because the next one on the count of 3 is 1, 2, 3. 18. Yay. And the next one, 1, 2, 3. 54. And the next one, 1, 2, 3. 162. Yeah. Okay, no biggie. Kind of nice though. So those of you going to computers, you'll have a little bit of a window into that idea. That's all I got for you today. We have some in-class exercises you can work on. Okay. I guess if you're gonna do it, now's the time.